All right, good morning. This is the notes on ions. So again, you should have already submitted your copy of your notes, and this is the notes is what they're going to look like for today concerning ions. Ions again are another change in regards to these atoms. So far, we've had that we can actually change the number of neutrons. Number of neutrons, that's an isotope, and we end up with different isotopes of the same element because of different numbers of neutrons, which also gives them a different mass. Then we talked about radioactive decay, and in case of radioactive decay, that was a really special circumstance where we can end up with different numbers of protons, extremely unique, but as things decay, they can change that, which changes them into a different element, which was supposed to be impossible according to Dalton's atomic theory. Now the third particle is electrons, right? We can change the number of electrons. Now this is, now I left it until the last thing to this chapter, because this is a really big key to the rest of this course. And that is, this change in electrons is going to be an extremely important piece to how these atoms come together and make compounds. All right, so in these notes it says ions. Ions are positively or negatively charged atoms. So they're atoms that have a positive or negative charge. If you remember back at the beginning of this section, we talked about how these atoms are electrically neutral. Neutral means they have no charge. And at the beginning of this, we said that protons and electrons are the same number. And if they're the same number, then they cancel each other out. So we wouldn't have an overall charge. Now all of a sudden we're going to have either more protons or we're going to have more electrons. And because we have more of one of those, we're either going to end up with a positive charge or we're going to end up with a negative charge. So in order to become an ion, what they have to do is they either lose or gain electrons. We aren't going to change the number of protons because from what we talked about in radioactivity, if I change the number of protons, then now all of a sudden I have a totally different element. Can't do that. That's extremely rare in the case, only in the cases of radioactive decay. In general, things that go on around us, like inside of our body and all the stuff that's around us, that doesn't happen very often. This stuff, this idea of formation of ions, happens a lot. All right, and in order for that to happen, we're going to lose or gain electrons. So the example I gave you is sodium. And if we have sodium, well, sodium, he's got 11 protons, and it's also got 11 electrons. So that would be its neutral state. Because what does it got overall? Well, nothing. Everything balances out. For every proton, there's a negative electron, and they cancel each other out. So we end up with nothing overall. But we can end up with sodium with a positive 1 charge. In order to be a positive 1, he's still got 11 protons, because that's what makes him sodium, because his atomic number is 11. Okay? But then in this case, he's lost an electron. Now he's got 1 less electron. And with 1 less electron, what does he have extra? Well, 10 electrons will cancel out 10 protons. So we really have 1 proton left over. And protons are positively charged. So because we got 1 extra proton hanging out, that ends up making it so this sodium ends up with a positive 1 charge. Right? So now if I do the electron configuration for this guy, so I'll do this model. Right? And we put in his 11 electrons. He's got a 2, a 2, a 6. There's 10. And then he's got 1 way out here. Now what's going to happen is what atoms don't like is they don't like having any other number other than 8 electrons in their outermost ring. So right now his outermost ring is this one. He's got 1. So he's got 2 options he can do. He can bring in 7 more electrons and fill this thing all the way up. Or he could take this 1 electron and he could give it away, let it go floating away, and then there's nothing in that ring. So now this is his outermost ring. Does that ring have 8? 2 and a 6? Yep, that's 8. So then this atom would be happy. And by making him happy, then this is the way he likes to be. He actually doesn't like to be this way. This way drives him nuts. And he's like constantly looking for a place to get rid of that electron. And he will get rid of that electron really violently, actually. And which causes, if we take sodium all by itself in this form, right, with everything there, put him in water, he'll sizzle, start on fire, or explode to try and get rid of those electrons, or that 1 electron. When he gets rid of that one, oh, then he's like, man, this is so much nicer. And this would be the form that it takes when it's with chlorine and makes table salt or sodium chloride. Then he's like, this is cool, man. He's got no problems, and he's really comfortable inside of us, and he's really comfortable everywhere, so he doesn't explode, right? So they don't like having their normal electron configuration we started with. So now you might say, well, why in the world did we learn that? Well, we had to learn that in order to learn this piece, right? So this would be where that one electron disappears, right? And they're trying to get rid of or gain electrons to try and get 8 electrons in their outermost ring. So now we look at another case of this, which is in your notes. Let's do sulfur. So if we got sulfur, he's got 16. So he would have 16 protons and 16 electrons. That would make him have nothing extra. Okay, so he's got no charge. But then if we make sulfur, and he's going to end up with a -2 charge. In order to do this, he's still got 16 protons, because that's his atomic number. But now what he did is he actually gained 2 electrons. So the 16 protons will cancel out 16 electrons, and we have 2 extra electrons left over. And electrons have a negative charge, so 2 of them gives me a -2 charge for this guy. So now if we do this thing again for this one, so I'll draw it again. So this guy's got 16, so it's 2, 2, 6, 2, 4. There's his electron configuration. Now remember what I just said a moment ago? That outermost ring, this one right here that's got electrons in it, he wants to have 8 in there. What's going to be easier? Is it going to be easier to get rid of that 2 and that 4, which is 6 of them? Or is it going to be easier to pull in 2? Always think the smaller number, right? So it's going to be easier for him to pull in 2 extra electrons. So he's going to end up adding 2 more to this and make this a total of 6. So when he brings in 2 more electrons and does this, now all of a sudden he's got 2, 4, 10, and then we got 18, so that's got 18 electrons, but he's still got 16 protons. He ends up with a -2 charge. Now again, just like the sodium, this is being an ion, having that charge. That's what sulfur likes to be. It doesn't like to be the normal electron configuration that we started with, right? So he's trying to become like this ion, and that's where they like to be. So, all right. Well, that actually concludes our notes on this. So the goal to this and making ions, and we will come back to this again in an upcoming chapter again, because again, this is a key to the rest of this course, is they're always trying to get 8 in that outermost ring. They're either going to lose electrons or they're going to gain electrons. And that's how they get to that number 8. If they're not going to change that number of protons, if they change the number of protons, it's a totally different element. Can't do that. And all we can do is change the number of electrons in this case to make an ion. All right, again, that concludes our notes for today. Have a great day. We'll see you.